So in this topology, we already have all the prefixes. We can confirm that if we have all the prefixes or not. So maybe I can go on router number 3, let's say. And on router number 3, we can check if we have all the prefixes or not. So let's go on router number 3. And this is OSPF, like we are running OSPF here. We can confirm show IP route OSPF that we have some inter-area prefixes, we have some intra-area prefixes. Apart from that, we have some external prefixes as well. So we must see that external type 2 prefixes are there. So we are receiving like quite a lot of prefixes. Okay, I'm not receiving 130 subnets. Let me cross check why we are not receiving 130 prefixes. So show run pipe section router OSPF. Redistribute rip metric 1, that is fine. Show IP OSPF database, NSS external. Yes, LSAs are there. Then why we are not having the type 2 LSAs for 130 subnets? Let me check. So 120 is there, 130 is not there. Okay, show run, show IP OSPF database. Okay. So here we are not receiving the prefixes. I observed that we are not receiving the prefixes here. We are not receiving these 130 prefixes here, or anywhere. So when I checked the configuration on router number 8, I found out that here we are using a command called no redistribution. That means on that router, the redistribution will not take place. So actually we need to remove that command so that we receive the rest of the prefixes. So when we remove that command, we should see the external prefixes. We should see that we are receiving those 130 submits as well. Yes, now it's okay. So we are receiving like 120 prefixes, we are receiving 130 prefixes, we are receiving like other inter-area, intra-area prefixes. So now we need to use variety of route filtering techniques to perform route filtering in this scenario. Here in this topology, we are running protocols such as OSPF, we are running protocols such as EIGRP, we are running protocols such as RIP. So we will be able to perform the route distribution in like all these protocols. Although we don't need to worry about the RIP routing protocol, so we'll focus very little on the RIP routing protocol. We'll focus more on the OSPF and EIGRP from the route filtering point of view. Okay, so what I'm going to do here, I'm going to add one more cable between router number 11 and router number 12. And that is going to be FA 0 by 1. I have added one more cable there. And I'm going to add one more cable here as well. So this is going to be under the router 8 and router 13. So I have added like one more cable here as well. So we have added like multiple cables between router number 8 and 13. And we have added multiple cables between router 11 and 12. Why? Because we want to receive the same routes on multiple links so that we can either select one link over the another link, or we can filter the routes from one link over the other link. So I'm just going to configure the IP addresses on there. So configure terminal FA 0 by 1 IP address is going to be whatever, like 100.1.1.12, does not matter, no shut. And since we configured EIGRP network 000, do show run pipe section router EIGRP. Since we configure network 000, as soon as we configure this new link, the EIGRP will get enabled there automatically. So we no need to enable it because network 000 command is running. We will go to router 11, configure terminal, router interface, FA 0 by 1, IP address 100.1.1.11, 255.255.255.0, no shut, router EIGRP, network 100.1.1.0, I have configured. So now in between these two devices, like router 11 and router 12, EIGRP is enabled on FA 0 by 1 interface and EIGRP is enabled on FA 0 by 0 interface. And both of these interfaces are practically identical. Like this is the fast Ethernet, this is the fast Ethernet, same bandwidth, load, delay, reliability, MTU. Every configuration is going to remain the same. And that is why if you go to router number 12, you should see that show IP route EIGRP, you should see that in EIGRP, we are receiving all the same prefixes from multiple links. We are receiving them from 112 and we are receiving them from 100. So all the prefixes on router number 12, we are receiving from multiple links like this link and this link. And now we might want to perform some sort of filtering. We want to prefer one link over another link. We want to do some sort of route filtering that can be done now. Same thing, I will go on router number 8 and router number 13 as well. In between router 8 and 13, router 8 and 13, I have added one more cable. So configure terminal, interface, IP address, whatever you want to configure, you can configure it. And here also, since we have used do show run pipe section router RIP, here also, since we have used network 0000, so RIP gets enabled onto that interface automatically. So I just need to configure the IP address there. The router 13 FS0/0 configured with the IP address, and I will go to router 8 as well. On router 8, configure terminal, interface FS0/1, IP address 200.1.1. It is 8.255.255.255.0 and router RIP and network 200.1.1.0. So I have added one more link between router 8 and 13, configured it with some IP address. The IP address that I have given here is 200.1.1.subnet. And once we have configured the IP address, I can confirm that I can go to router number 13 and all the routes that we were receiving earlier only from one path. Now we are receiving those prefixes from multiple paths. RIP sends the update in every 30 seconds. So you might need to wait a little bit before you receive the update. Once it has been 30 seconds, you will receive those updates from multiple paths. So you just need to wait. So just like, for example, here, we have received one prefix from multiple path, you will receive the rest of the prefixes from multiple path as well. And as you can see, RIP takes quite a lot of time. Like some prefixes are coming from one path, some prefixes are not coming. So RIP takes quite a lot of time. So you have to be patient. You have to have some patience. So like now you can see that here, now we are receiving the prefixes from both the path. RIP converts very slowly. So RIP takes some time in convergence and also. Okay. Why I'm not receiving 120 subnets? Let me cross check that as well. Oh, 120 subnets we will not receive because we have configured this area as NSSA. So since it is configured as NSSA, these prefixes will not be allowed to go here. Right, but since we have the default route will be advertised here, and following the default route, the reachability can be ensured. On router 5, on router 6, we have used the either default information originate command, or we have configured totally NSSA, where the router generates the default route automatically. So this device is going to advertise the route anyway. So anyway, we have the reachability end to end, and now we have all the routes end to end, and now we can perform route route filtering on these devices. So let's say, for example, when it comes to route filtering, we have quite a lot of ways that we can use to perform the route filtering between the devices. The easiest way to perform, we are talking about route filtering, and maybe like I want to prefer one path over the another path, like primary, secondary. Maybe we don't want to filter the route. Maybe we do not want to filter the route. We just want to configure one route as one path as our primary path and the second path as the secondary path. So not necessarily that you have to filter all the routes. So route filtering, however, route filtering basically means we are going to filter all the routes, but not necessarily you need to filter. You can also, like, for example, choose one path as the best path and the other paths as the backup path. So route filtering and path manipulation, basically we are talking about in case of IGP protocol, how we can influence the best path selection in case of IGP protocol. So the easiest way to perform the route filtering, is going to be the AD value. By using the AD value, administrative distance value, the easiest way to perform the route filtering is that we can use the AD value. We can set the AD value to 255 to perform the route filtering. This is the easiest way to perform the route filtering. So what I want to do, I want to filter all the prefixes. I can filter all the prefixes by setting the administrative distance value to 255. So, okay. So for example, in this topology on router number 11, I do not want to receive any of the EIGRP prefixes. I do not want to receive any of the EIGRP prefixes. So I can go on there on router number 11 or maybe on router number 12, whatever, doesn't matter. You can just say, I want to filter all the prefixes. I do not want to receive any prefixes from EIGRP. I do not want to receive all these prefixes from EIGRP. So what you can do, you can say router EIGRP 100 and you can use the command distance EIGRP and you can set the administrative distance value for internal route and you can set the administrative distance value for external route. Basically, by executing this command, what we have done, you have set the administrative distance value to 255 for internal route. You have set the administrative distance value to 255 for external route. All right, so distance EIGRP, AD for internal route, AD for external route. So you change the AD value to 55 for internal and external. As a result, you can confirm that you do not have any route in your routing table. So as simple as this, we can filter the routes with the help of the AD value. Similar thing you can do in the OSPF, like you can use the commands in OSPF routing protocol as well. Similar set of commands, such as, for example, you can go to router number 3, configure terminal, router OSPF, distance, OSPF, then AD for external route, AD for inter-area route, and AD for intra-area route. We can configure to 255. Once we configure the administrative distance value to 255, those routes are going to be filtered. So distance OSPF external, this inter-area, intra-area, I have set all the administrative distance value to 255 and do show IP route OSPF. You can see that routes are no longer there. Same thing you could have done on the RIP routing protocol. Maybe you can go to router number 13, configure terminal, router RIP, same command, distance. Here you can configure the AD value to 255, just simply. Distance to 55. This command is going to change the AD value to 255 for all the RIP prefixes. Now remember, in the RIP routing protocol, it takes some time. So once you set the administrative distance value to 255, you might not see the convergence right away. You might not see that the routes are getting filtered right away. So do show IP route RIP. You can see that the routes are still there, but these are invalid now. Because in RIP, the timer is like the RIP sends periodic update in every 30 seconds. And since the timer has gone beyond 30 seconds, it means that these routes will be filtered. But in RIP routing protocol, it could take up to 4 minutes to perform the filtering or any changes. In RIP routing protocol, changes could take approximately 4 minutes, like 240 seconds in total for convergence and all. So forget about it. So you want to check it. You want to filter the prefixes right away. Just use the command clear IP route star. This command is going to clear the routing table completely. And now this router is going to wait to receive the route from the neighbor router. So this command is going to clear the routing table. This command means clear all the routes from the routing table. Star means all. So clear IP route star means clear entire routes, all the routes from the routing table. And now if you check show IP route RIP, you don't see any route because routes have been filtered. So in every protocol, we have this command distance. Using the distance command, we can use the route filtering. We can filter the routes based on our requirement. Right, we can just go under the router EIGRP, that is 100, and use the command like no distance or distance, whatever command we have used. You can just negate that command so that the routes again gets installed in the routing table. Otherwise, like if you set the AD value to 255, the route is going to be filtered. A route with the AD value of 255 never gets installed in the routing table. One thing to keep in mind about this AD value, any sort of route filtering that we perform in OSPF routing protocol. One thing you must keep in mind about any route filtering technique that you do in OSPF routing protocol. One thing you must understand that in case of OSPF routing protocol, let's say I went on router number 3, I said that I want to filter all the prefixes, and to do that, what I have done, I have changed the AD value. And the same thing what I'm going to do the same thing on router number 4 as well. Here, like configure terminal, and here also I'm going to use the same command. Basically on router 3 and router 4, on these two routers, I have set the administrative distance value to 255 for all the prefixes. That means on router number 3, do show IP route OSPF, and on router number 4, do show IP route OSPF. On both the routers, We do not have the OSPF routes. But remember, like if you go to router number 5, maybe, let's go to router number 5, maybe, go to router number 7, maybe, like you go to router number 7, maybe, and here you check show IP route OSPF, you are receiving all the prefixes. You are receiving like 9.9.9 prefixes, which is router 9 prefixes. You are receiving like 5.5 prefixes, 4. We are receiving all the prefixes actually. So prefixes are not available on router 3, prefixes are not available on router 4, but the prefixes are available on router 5, router 6, router 7, router 8. These prefixes are available on router 1, router 2, router 9, router 10, router 11. Those are there. We do not have routes here, but we have the routes here and we have the routes here. And why is that? Because when we talk about the route filtering in protocols such as OSPF, the command that we have just executed is going to filter the routes, but this command cannot filter the LSAs. So this router has advertised the LSA to router number 3. Router 3 has advertised that LSA to the neighbor devices. Router 5 has advertised the LSA to the neighbor devices. And because these routers are still receiving the LSAs, they can calculate the route. So the point is that in case of protocols such as OSPF, OSPF is going to, like, route filtering techniques are going to filter the routes. Route filtering techniques such as distance, such as ACL, such as prefix list, whatever, they are going to filter the routes. However, in OSPF, we exchange the information in the format of LSAs. So route got filtered, that is okay, but LSAs got exchanged. So the routes are available here. Of course, you will not be able to ping from here to here because these routers, they don't have the route. But again, in OSPF protocol, it is completely possible that these routers, they don't have the route, but these routers, they have the route. Because route filtering techniques filter the routes and OSPF exchanges the LSAs. And since OSPF exchanges the LSAs can be available. LSAs are in fact available on all these routers. As a result, these routes are available here and these routes are available still here. You will not be able to ping because these routers are not having the routes. Right, so this is not possible in the distance vector protocol such as EIGRP. If with the help of EIGRP, I perform the route filtering on router 3 and router 4, those routes will not be available on router 5, 6, 7, 8, because EIGRP can only advertise the best route information to the neighbor router. And since the router itself is not having any route as the best route to reach to the destination, it cannot advertise it to the neighbor router. So yeah, in case of protocols such as OSPF, it is completely possible that some routers don't have the route, but some routers have the route because the way OSPF exchanges the information. This is it. This is how we can we can filter the prefixes with the help of the ADI. Now, the problem in this approach is that we are not able to select what route we want to filter. This command is just going to filter all the prefixes, all the external prefixes, all the inter-area prefixes, all the intra-area prefixes. This command is just going to filter all the prefixes. We cannot select like what prefixes we want to filter, from where we want to do the filtering. For example, maybe I do not want to filter the prefixes on both the link. I want to filter the prefixes only on this link. I want that this router must not receive any prefixes on FA0/0, but it must receive all the prefixes on FA0/1. The command that we just executed is not going to help you in that. This command is just going to filter the prefixes. This command is just going to filter all the prefixes, in short. So we do have the options for the same. In OSPF, in EIGRP, in protocols such as RIP, it is possible that we can filter the prefixes from one particular source. Like when I receive the prefix from this particular source IP, then I am going to filter it only. If I'm receiving the prefixes from this source IP, then I'm going to filter it only. If I'm receiving the prefixes from this source IP, I am going to allow it. It is possible in protocols such as RIP, it is possible in protocols such as EIGRP, OSPF that we can filter the prefixes based on the source. Like for example, router RIP, I can see that do show IP route RIP I can see that I am receiving the prefixes on both of the interface, FA0 by 1, FA0 by 0. I can confirm it from here. And when I'm receiving the prefixes from FA0 by 0, what is the source of that particular update message? 200.1.1.8. This is the source of that update message. And when I am receiving the prefixes on FA0 by 0, on FA0 by 1, this is the source of the update message. On FA0 by 0, this is the source of the update message. I do not want to receive any prefixes from here. So I can just use the command distance to 55, and then I can specify the source address. I can specify that I do not want to receive any prefixes from here. And we need to specify this thing called wildcard mask like 0000, which just tells the operating system, which just tells the iOS that you have to match exactly this IP address. When the routing update comes, when the routing update is received on router number 13, when the routing update is received on the router number 13, if that routing update has the source IP address of 130.1.1.8 exactly, then you need to set the AD value to 255 for those prefixes. So distance to 55, and here we can mention the source. This command we can use to mention the source. Same thing we can do on here as well, on router 11 as well. Instead of using the command distance EIGRP, don't use this command. Use command distance to 55 and use the source. Like on the router number 11, I am receiving all the EIGRP prefixes from 100 as well as 112. Maybe I want to filter all those prefixes from here. So I can use the command distance like 255, and then this and the wildcard mask. So this means, like I'm telling the EIGRP router that when you receive any prefix, any routing update, if you receive the update message and that update message has the source IP of this one, you do not need to accept it. You need to set the administrative distance value to 255 for all the routes that you have received from this specific source. As a result, if you check do show IP route EIGRP, you can check that we no longer are receiving the prefixes from two paths. We are just receiving the prefixes from one path. Earlier, we were receiving the prefixes from both of the paths. But now, since we did route filtering from this particular path, I do not want to receive any prefix from that particular path. So I am no longer receiving the prefixes from that path. I am receiving the prefixes from one path only, FA0 by 1. Remember that this command only works in EIGRP. This command only works on internal prefixes. This command does not work on external prefixes. This command will not work in EIGRP for external prefixes. You cannot execute this command for external prefixes. Means, if I go to router number 12, on router number 12, we are receiving all these prefixes from both of the paths. We are receiving all these prefixes from both of the paths. And if I try to do this router EIGRP 100, then distance to 55, and I try to filter it from one of the path, maybe from here, I can see, let this information get resynced. This command that we have executed here, distance to 55, 100.1.1.11, that I want to set the AD value to 255 for all the prefixes that I have received from this particular source. So I saw that on router 11, it did the route filtering, it did filter the prefixes. But if I go to router number 12, do show IP route EIGRP, I can confirm that the prefixes are not getting filtered. I have executed the correct command, but the prefixes are not getting filtered because this command actually works only and only for the internal prefixes. It does not work on the prefixes that got redistributed into the EIGRP. And since all the prefixes that I am receiving on router number 12, all these prefixes are redistributed into EIGRP, that command is not working for them. So the command that we just executed is going to be run. It will run only for internal prefixes in EIGRP. Right. So do show history. This command will not work for external prefixes in EIGRP. This command will only work for internal prefixes in EIGRP. You can check that once we execute that command, you can check that you no longer have the routes from both of the path, but you have the routes only from one path. So we can do the route filtering as per our requirement. We can do the route filtering as per our requirement. You can see that. Like we can filter that if the updates are received from one specific source, I'm going to filter them. So we can also mention the source of the update message. We can mention the source of the update message. Once we have mentioned the source of the update message, the router is going to perform the route filtering based on that source IP. So when the update is received on FA0x1 interface, then it will have the source IP of 138.1.1.8, and as a result, that will be filtered. Okay. Still, now if you want to do the same on router OSPF, you can do it by yourself. You can go to router number. You can go to router number 3. You can go to router number 4 and do the same in router OSPF by yourself. No, a route with the AD value of 255 will never get installed in the routing table, no matter if that is the only path available. So no, if the primary path goes down, the path with the AD value of 255 will not be installed in the routing table. That is why, like, you might not want to do the filtering. Instead of doing the filtering, you could have done this. Instead of doing the filtering, what you could have done this, you could have done this. Like maybe we want to configure this path as the primary path, and since we don't want the route to be sent, we don't want the traffic to be sent from this other path. So instead of doing the route filtering, what we could have done, we could have done router rip, and we could have said like distance. Instead of setting to 255, I could have set like maybe 200, not the 255. So do clear IP route star. So now what we have done, instead of setting the administrative distance value of 255, I set the AD value of 200. I have set the AD value of 200, which means like when the prefixes are received onto this particular interface, the AD value will be 200. And when the prefixes are received onto this particular interface, the administrative distance value is going to be 120 because of RIP. So now if you check the routing table, do show IP route RIP, you can check that the router has installed the path FA0x1, FA0x1, FA0x1. The router has installed the path that has the lower AD value 120. That router has installed the path with a lower AD value, that is completely fine. But if that link goes down due to some reason, let's say for example the interface FA0x1 goes down due to some reason, if this interface goes down, the other path will come into the picture now. Do show IP route RIP, and the other path gets installed in the routing table that had the higher AD value. Just like we did in static routing, we could have like instead of setting the AD value to 255, we could have set the AD value to something other than 255 so that we can have some sort of primary secondary concept as well. Right. So your choice if you want to filter or you want to do path manipulation. You want to prefer one like primary secondary. If you want to do, you can do primary secondary, completely up to you. Otherwise you can filter the second path completely. Maybe you don't want to receive the prefixes from one path, so you can just filter it. Otherwise you can basically set the AD value to higher AD value from the other path so that that path is only chosen when the primary path goes down. So primary secondary game you can also do here, just like you did in static routing. So primary secondary we can do here as well. Now, still, we have not specified what prefixes. We said that all the prefixes that you receive from here, set the AD value, set the administrative distance value to 200. I still did not specify what prefixes. I said like this command is going to say, this command is going to tell the operating system, this command is going to tell the router number 13 that he had to set the AD value to 200 for all the prefixes that you receive from this particular source. We still have not defined what prefixes. We still have not defined here what prefixes. We still have not defined which prefixes like I want to influence. This command, distance, This command distance to 55 is going to set the AD to 255 for the prefixes. We can also do it from a specific source, that is fine. But I also want to have the AD getting changed for specific routes. I don't want to change the AD for all the prefixes. I do not want to change the AD value for all the prefixes. I want that this may be router number 11, maybe show IP route EIGRP. What I want that I want only and only for these three prefixes. I want that only these three prefixes. I want to change the administrative distance value only for these three prefixes. I want to change the AD value for only and only for these three prefixes. So what we can do, configure terminal, router EIGRP, distance, either you can set it 255, whatever you want to set, 200, whatever you want to set, completely your choice, distance 200. And then from where, when the prefixes are received from this particular source, okay. And just after that, we can also tell this operating system, we can also tell this router 11 that when we receive certain prefixes from this source, not all the prefixes, when we receive these prefixes from this source, then only set the AD value to 255. And that, like what prefixes I want to change the AD value for, that thing can be specified just after that by using this concept called ACL. We can configure here an ACL. We can write down here with an ACL number or name that I want to change the AD value to 200 when I receive these prefixes from this particular source, such as, for example, 50. And now I'm going to create an access list 50, and what prefixes? Permit the prefixes 120.1 prefix. Okay, this is one prefix, this is second prefix, and this is third prefix. So I configured an access control list. In that access control list, I matched 120.1.1.0, 120.1.2.0, 120.1.3.0/24/24/24. I have matched the prefixes in our ACL, and I have referenced that ACL right here. I have called that ACL right here. So I said EIGRP, I asked the EIGRP to change the AD value to 200 for these prefixes when they are received only from here. And you check it now, do show IP route EIGRP. You can see that the AD got changed for this subnet. I can also do like clear IP EIGRP neighbor ones so that the prefixes get received again. Let's check it again. So now you can see that these three prefixes, only for these three prefixes, 1, 2, and 3, only for these three prefixes, you can notice that only for these three prefixes, AD got changed from the other path, from this path. But for the 4.4 and 5.5, for 4.0, 5.0, the AD is exactly the same as it was earlier from both the paths. So we can also mention just after that an ACL. In that ACL, we can match our desired prefixes for which we want to perform the path manipulation, or maybe we want to filter. If you want to filter, set the AD to 255. If you want to have primary, secondary, set the AD value to other than 255. Right. So access list 50 permit, and then configure an ACL. In that ACL, match your desired prefixes, and then use the AD command, then use the distance command for the same. Same thing you can do in RIP. You can go to router number 13, and just after this command, you can also mention here the AD will, the ACL, do it yourself. You can go on router number, maybe OSPF, maybe router number 3, and distance, like I can say 100, and then we can specify the source, maybe 5.5.5, and then we can specify the AD here as well. Sorry, ACL here as well. So same set of commands. We have 3 commands now in total. We have the command, simple command distance. Then we have command distance plus we have like distance plus source. And we have command like distance plus source and plus ACL. So whichever is required as per your requirement, you can use either this one, or you can use this one, or you can use this one completely. Now remember that in case of OSPF, since OSPF exchanges the LSAs, remember that in OSPF routing protocol, when we want to mention the source of the update message, remember that OSPF routing protocol actually exchanges the information in the format of LSAs, and LSAs have the OSPF router ID as the source ID. So source in case of OSPF should be the router ID of the router from where the LSA is being received, like advertising router ID. In case of OSPF, here we cannot specify the IP address. Here we need to specify the router ID. Because in OSPF, the information is exchanged in the format of LSAs. In OSPF, information is exchanged in the format of LSAs, and LSAs have that field called advertising router ID. So you need to mention that when you receive the prefixes from 1.1.1.1, or when you receive the prefixes from 2.2.2.2, then only you need to perform the filtering. So in case of OSPF, in case of open shortest path first, instead of configuring, instead of specifying the IP address, we need to specify the source router ID. Because in OSPF, the information is exchanged in the format of LSAs, and LSAs have the advertising router ID. So in case of OSPF, instead of defining, instead of configuring, instead of defining the source IP address, we need to specify the router ID of the router from where the LSA is being received. This is how we can use the administrative distance value AD to either filter the prefixes or influence the prefixes as per our requirement. If you set the AD value to 255, it will filter the prefixes. Otherwise, if you set the AD value to other than 255, less than 255, whatever AD value you have set, then the prefix is not going to be filtered. It is like manipulation you have done, like best path, backup path, or primary, secondary. You have done. Okay, done. Any doubts if you have, you can let me know. This is AD, administrative distance. Okay. Now, let's say they have asked us not to use the AD value. So maybe we are not allowed to change the AD value. So we are not going to use the AD value. Let's say that we are not allowed to change the administrative distance value. So we are not changing the AD value. We are not changing the AD value. So AD value is set to whatever it was earlier. We have not changed the AD value. So that is fine. The second option that we have, remember that with the help of the AD value, we can do two things. We can either filter the prefixes or we can influence the prefixes as per the requirement. But when it comes to like the second option where we have the ACL, we can configure the access list. We can configure the ACL. We can use the access control list to filter the prefixes as well.